Good day, everyone. In preparation for our quarter examination, we will now have our review about complex rational expression. Here's our example number 1. 1 over x minus 1 all over x over 3 plus 3. The very first thing that you need to do is to find the LCD of all the denominators that we see in a complex fraction. So we have here x and 3. So you need to find the LCD, and the LCD for that would be 3x. Once you have your LCD, you need to multiply the LCD 3x to both the numerator and denominator. So enclose the numerator 1 over x minus 1 and then multiply it to 3x, and the denominator x over 3 plus 3, you have to multiply it as well with 3x. After that, you need to distribute the 3x to both terms. So first, you need to multiply 3x to 1 over x. That will give you 3. This is the common mistake of other students. They don't usually multiply the 3x to the second term. So take note, it must be distributed to both terms. 3x times 1 will give you negative 3x. You have to do the same thing in the denominator. 3x should be multiplied to x over 3. 3x times x over 3 will give you x squared. And as I said in the numerator, the common mistake of other students, they tend to forget the idea that the term 3x should be multiplied in both terms and are x over 3 plus 3. So multiply 3x times 3, and that will give you a 9x. Since we cannot simplify anymore, 3 minus 3x all over x squared plus 9x, that would be our final answer. So this is now the simplest form of our complex rational expression. Let's now have our example number 2. In our example number 2, we have here 2 plus 2 over y minus 2 all over 2 minus 2 over y minus 2. So similar to what we did in our previous example, we need to find first the LCD of the denominators. So we have y minus 2 and y minus 2 as well in the denominator. So that means the LCD of those that were highlighted, y minus 1, y minus 2, is still y minus 2. So you need to enclose the numerator of the complex fraction with a parenthesis and multiply it with the LCD y minus 2. You have to do the same thing in the denominator, 2 minus 2 over y minus 2, and you need to multiply it as well in the LCD y minus 2. Similar process, you need to distribute the y minus 2 to each terms of our binomial. Y minus 2 must be multiplied to the 2. Let's not simplify that yet. So we just have to copy that. And then if you multiply the LCD y minus 2 to 2 over y minus 2, that will give you a 2. And in the denominator, you do the same thing. Y minus 2 must be multiplied to the 2. So that will give you 2 times the quantity of y minus 2. And you multiply as well the y minus 2 to the second term, 2 over y minus 2. That will give you a minus 2. So now we just have to simplify both numerator and denominator separately by distributing first the 2 to the y. So 2 times y is 2y. And if you multiply the 2 to the negative 2, that will give you a negative 4. Same process in the denominator. Multiply the 2 to the y. That will give you a 2y. and 2 times negative 2 is negative 4. We can still simplify our answer here by combining the constant terms, negative 4 and 2. So negative 4 plus 2 is negative 2, and negative 4 minus 2, they have the same sign. So you need to add the absolute value of those two numbers and copy the common sign. That will give you a negative 6. Then finally, we can still apply our knowledge of factoring to further simplify the expression. So you can find the GCF of 2y minus 2, which is 2. Factor it out and you will have y minus 1. And in the denominator 2y minus 6, the GCF is 2. And once you factor out the 2, that would be y minus 3 as the remaining term. Now you can cancel out the common factors in the numerator and denominator. And that will give you y minus 1 all over y minus 3. And that is our final answer. Let's now proceed to our last example. 5 over y plus 2 minus 7 over y minus 2 all over 4 over y squared minus 4 plus 5 over y plus 2. Similar process, we need to figure out or identify the denominators of the fractions inside our complex fraction. That would be y plus 2, y minus 2, y squared minus 4, and y plus 2. So if you figure out the LCD of that one, you have y plus 2. You can further factor that. Y minus 2, same. You cannot further factor it. But for y squared minus 4, wait, let me just erase something. So let me repeat, the y plus 2 can't be further factored anymore. Same with the y minus 2. But for y squared minus 4, you can factor that using difference of two squares. So if you factor that using difference of two squares, that would be y plus 2 times the quantity of y minus 2. And finally, the fourth denominator is just y plus 2. So you have to align that with a or the same factor indicated above it. So you just have to bring that down. That would be y plus 2. And the other one is y minus 2. So therefore, the LCD here is y plus 2 times the quantity of y minus 2. So let me just erase this for us to have a space our solution. But again, as I said a while ago, the LCD here is y plus 2 times the quantity of y minus 2. Same in our process a while ago, in our complex fraction, you need to multiply the LCD to its numerator. So don't forget that the numerator must be enclosed in a parenthesis to avoid errors. The denominator as well, you do the same thing. You enclose the entire denominator of the complex fraction, then multiply with the LCD. Now we distribute the LCD to each terms. So LCD times the first fraction in here, the first term, will be able to cancel out the y plus 2. What will be left is just 5 times the quantity of y minus 2. Multiply the LCD again to the second term, 7 over y plus 2. The y plus 2 will be cancelled out. what will be left is just the minus 7 times the quantity of y minus 2. In the denominator, you also distribute the LCD to each terms of our denominator. So if you multiply that, the y squared minus 4, if you factor that out, that's y plus 2 times the quantity of y minus 2. So everything will be cancelled out, and what will be left is just 4. Then LCD multiplied to the second term, the y plus 2 will be cancelled out, and what will be left is just 5, and the y minus 2. Then what you will do now is distribute the 5 to the y minus 2. So 5 times y is 5y, and 5 times negative 2 is negative 10. Then here, in this is negative 7, so despite the fact that this is a minus, we can consider it as plus negative 7 to avoid confusion. So you can treat this sign here as a negative sign instead of a minus. So negative 7 times y, that will give us a negative 7y. Negative 7 must be multiplied as well to negative 2. Negative 7 times negative 2 is positive 13. Then in the denominator, we now distribute the 5 to the y and 2. So 5 times y, that will give us a 5y, and 5 multiplied to negative 2 is negative 10. Then finally, we apply our knowledge on how to combine like terms. 5y and 7y are like terms. 5y minus 7y is negative 2y. Negative 10 and 14, they're both constant terms with no variable. So negative 10 plus 14 is positive 4. And in the denominator, we have 4 and 10. So 4 minus 10 is negative 6. Then the 5y doesn't have a like term, so you just have to copy it. Then double check if you can still do factoring and cancel out the common factor in the numerator and denominator. But by checking the denominator, you can factor it further. So that means this is our final answer. This is the simplest form of our complex fraction. So the answer is negative 2y plus 4 all over 5y minus 6. That's it for our part 1 reviewer for our quarter examination. Thank you so much.